Welcome back. Today's lesson is on adding and subtracting rational expressions. Last time we looked at multiplying and dividing. Today we look at adding and subtracting. Since rational expressions are just fractions with polynomials in them, we can apply a lot of the same things that we know from adding strictly numerical fractions. For example, if we were adding 1/2 plus 1/3, what would we need? That's right, we would need a common denominator. And so we'd be looking for the least common multiple of 2 and 3. That happens to be a 6. So convert both of these fractions into something over 6. Well, 1/2 is the same as 3/6. 1/3 is the same as 2/6. And at this point, we add the numerators. 3 plus 2 makes 5. And so we get 5 over 6. Adding rational expressions also requires finding a common denominator, and this often means that we have some factoring in our future. For example, we have x over x squared plus 5x plus 6, and we're going to add to that 2 over x squared plus 4x plus 4. It would be very, very useful to us if we factored each denominator on our way to finding a common denominator, and we know that the first denominator is x plus 3 times x plus 2. The second denominator, x squared plus 4x plus 4, that'll factor as x plus 2 times x plus 2. So the least common denominator needs to include this x plus 3. It certainly needs to include this x plus 2, but we've already got one of those over here, so we've covered that, except in the second denominator there's another x plus 2. So the least common denominator that we're aiming for is x plus 3 times x plus 2 times another x plus 2. And to do that, to get there, we'll take the first rational expression, multiply top and bottom by an x plus 2. That way we've met the common denominator. And in the second fraction, we need to multiply top and bottom by x plus 3. Remember, if you do something to the top of the fraction, you must do the same thing to the bottom in order to keep them equivalent. And from here, we will distribute the x to the x plus 2 and distribute the 2 to the x plus 3. And while we're at it, we'll combine these into one big fraction because they do have the same denominator. X times x is x squared. X times 2 is 2x. We can add to that the quantity 2 times x plus 2 times 3, which is 6. And we'll put this all over the common denominator. X plus 2, x plus 3, x plus 2. Remember that multiplication is commutative, so it really doesn't matter what order those factors are in as long as they're all there. And no, you do not need to multiply them back out. You can leave them in the factored version. And so combining like terms in the numerator, well, that x squared's not combining with anything, but 2x plus 2x makes 4x, and then the 6 doesn't combine. And so we finish with x squared plus 4x plus 6 over x plus 2 times x plus 3 times x plus 2. There is only one thing left to include here, and that's a statement of what we will not allow x to be, the domain restrictions, as we've talked about in previous videos. We would have a problem if x were negative 2. So don't let x be negative 2. We would also have a problem if x was negative 3. And we would want to look at the third one here, but we've already covered that x plus 2 equals 0 if x is negative 2. We've already got that. Here are our domain restrictions, and we'll put a big box around everything so that we can indicate that all of this is the solution, not just the rational expression, but also the domain restrictions. We don't let x be negative 2 or negative 3, but the main part of the solution is x squared plus 4x plus 6 all over x plus 2, x plus 3, x plus 2. Same method applies with subtraction, but remember that when you are subtracting a polynomial, which we'll be doing shortly, you are subtracting every term in that polynomial. So first off, let's look for the common denominator. X plus 3 does not factor. However, x squared minus 9, that's x plus 3 times x minus 3. So it should be pretty clear that our least common denominator is x plus 3 times x minus 3. Both rational expressions have the x plus 3. The difference is that the first one does not have the x minus 3. So let's go ahead and put that in real quick. We'll multiply the top by x minus 3, and that means that we need to multiply the bottom by an x minus 3, and that will give us x times x minus 3 minus the 6x all over x plus 3 times x minus 3. Distribute across the across that first set of parentheses for x squared minus 3x, and then we also have the minus 6x. Put that over x plus 3 times x minus 3. And of course we need to combine like terms in the numerator, which we have. The x squared stays as x squared. However, negative 3x minus 6x makes negative 9x. And the denominator stays as x plus 3, x minus 3. Make sure that we have parentheses around each factor. And domain restrictions, x cannot be negative 3, else we'd have a problem with the first of the two factors, and it also can't be positive 3 because that would give us a problem with the second of the factors. And we'll say that our final answer is x squared minus 9x over x plus 3, x minus 3, along with the notation that we do not allow x to be negative 3 or positive 3. I have a feeling that you're starting to get the idea here. I hope you're getting the idea, so I'm going to give you this problem to try on your own. Be sure to include any of the domain restrictions. So first off, we're going for a least common denominator. The first denominator will factor out a 2, and we have 2 times the quantity x minus 3. In the second denominator, we'll factor out a 4 for 4 times the quantity x minus 3. So our least common denominator most definitely needs to have x minus 3 in it. What's the least common multiple of 2 and 4? Yeah, it's 4. So our least common denominator is 4 times the quantity x minus 3. So just like in the earlier problem, the one denominator is already where we need it to be. The other one just needs a little bit of an adjustment, and that means that we're going to multiply the first numerator by 2, and we'll multiply the first denominator by 2. So we have 2 times the quantity x minus 5, and again we are going to make one big denominator right away. Remember that you are subtracting the entire second, highlighter is wiping out what I had written. You are subtracting the entire second numerator. So that's why we're subtracting the quantity x minus 7, and the denominator is 4 times x minus 3. So as we simplify the numerator, we have 2 times x minus 2 times 5, which is 10, minus an x, minus negative 7, so we're going to add 7. So we have 2x minus 10 minus x plus 7, all over 4 times the quantity x minus 3. Combine like terms in the numerator. 2x minus x is a single x. Negative 10 plus 7 makes negative 3, and we're starting to see something interesting happen here. The numerator is a factor of the denominator. So we'll cancel out an x minus 3, top and bottom. Remember to cancel out the entire binomial and not just one term at a time. The only thing that's left in the numerator now is a 1. And so we finish with an answer that doesn't have any variables in it at all. It's just 1/4. And we need to include the statement that x is not allowed to be positive 3. And there's our final answer. And that's it for today's lesson. I'll see you next time. Thanks for watching.